Ladies and gentlemen, friends and colleagues, welcome to the evening of Computer Science ICBF 2024. In this evening, we gather to celebrate the advancement and achievements in the field of computer science and hear from the brilliant minds who have shaped ever-evolving discipline. Computer science profoundly impacts our world, driving innovation and transforming every aspect of our lives. We are privileged to have with us eminent figures in the field who will share their insights and expertise. Their contributions have not only advanced the boundary of computer science, but also inspired countless individuals worldwide. First of all, let's warmly welcome Professor Qingtong Yao, the chairman of the International Congress of Basic Science.
Well, ladies and gentlemen, I think this has been an exciting last few days for this big Congress, which I'm rather proud to say that is very successful. Today will be the day for engineer, and it's a very important subject, bridging fundamental science to industry. And this also very important for science itself, because science needs a lot of computation, a lot of important activities from computer. Many data needs to be clear, and many insight into science needs those machines, which is not possible otherwise. So there are many point of view about machines, whether they will be better than humans or not, whatnot. This is not my concern, friendly. My concern is whether the machine can help us to make progress in fundamental science, which needs the machine, and also to industry, of course. So I believe a joint conference like this are very useful, because clearly the many important advances in physics has been useful for building up computer industry, and many of the hardware and also theory was built on such a subject, especially the incoming quantum computation, which may be taking 10 to 20 years to develop, but still fundamental physics is a major building block. And of course, in many ways, I consider artificial intelligence is actually a branch of mathematics. And many important, interesting ideas of mathematics are used, and it will be used again and again. I think computer science and AI or whatnot would not make great advance without knowing enough mathematics. So we are proud to say that mathematicians would be able to make contribution to the subject, and we are ready to do so because many of us are interested in the subject itself also. So of course, my great friend Leslie Valiant has been doing that all along. He knows mathematics and also engineer. He trained his son to be really good. In fact, my son was very much nervous because taking a bus together with his son, who knew calculus when he was 6 years old. My son got very nervous about it. I'm just making a joke because it shows that Leslie has been very interested in mathematics all along. And I think this is an important trend. And the fact that we have 3 different subjects in this big conference, I think is a healthy thing. I have listened to several participants who said that they learned things from other subjects, which otherwise would not be possible. So I think this is a good thing. And I hope that we come together and without boundary, trying to learn from each other. I think we can promote science, not only for China, but also for the whole world. And this will be excellent. Thank you.
Thank you. Thank you, Professor Yao. Next, we have the honor of hearing from a luminary scholar in computer science. He is a member of both National Academy of Science of USA and the Royal Society of UK, and the 2010 Turing Award winner. Please welcome Professor Leslie Valent from Harvard University to the stage.
Thank you very much for inviting me here. I am particularly excited at being at this ICBS meeting because I've always found it difficult to separate mathematics, physics, and computer science. I'm one of those people who do think of the three subjects as being closely related with a few boundaries. So I'm very excited that this is, for once, we do have a meeting of sufficient breadth. I think one important thing for computer scientists coming here is to reflect on the fact that, in fact, some branches of mathematical sciences are much more ancient than computer science. So the first talk we heard from Andrew Wiles was in number theory, and there clearly you can connect up the centuries of number theory. So computer science is much newer, but it does demand of us to ask, where is computer science in this history? And so my take is that computer science is still at a very early stage of its history. Many open problems, the most basic open problems formulated are unresolved. So for example, the P equals NP question is totally unresolved. And so in fact, so one distinguished early pioneer of complexity theory was Joris Hartmanis, and he had this joke, I think it was a joke, that he said that all computer science departments should close down until we've resolved the P equals NP question, because if we don't understand the subject, we shouldn't teach it. I think he meant this as a joke, but then who knows? But in any case, I think that's the whole point about computer science, is that the questions asked at the beginning, which are fundamental, we just don't know answers to. So even how efficiently you can compute basic linear algebra, which is the basis of a lot of engineering and science, we just don't know. We're very early stage of understanding that. And of course, in computer science, there are always new questions which arise, which are injected into the field from elsewhere. So quantum computing, for example, raises lots of questions for computer scientists, people who develop algorithms, which kind of came from elsewhere. And all the time, new technology asks new questions. And of course, I think as everyone appreciates that the area of cognitive science and the computer science, the implementation in engineering called AI is particularly at a point of great excitement, and enormous opportunities in the future to contribute to it. So I think I just want to say that I believe computer science is at a very early stage, and there remain enormous opportunities for young people and old people to contribute to it in the future. Thank you.
Thank you, Professor Valent. Now we move on to the next exciting part of our evening. In this segment, we will hear from two distinguished IEEE fellows who have made significant contributions to both industry and academia. Our first keynote speaker is an influential figure in the world of artificial intelligence and computer vision. He has played a pivotal role in advancing this field through his groundbreaking work at Tencent. Please join me in welcoming Dr. Wei Liu from Tencent to the stage.
Sorry. Okay, thank you. Actually, this is my first English presentation in the past 5 years. Sorry. Yeah. And it's my great honor to be invited to attend this great conference. And I studied AI. I studied AI in over 20 years ago in AI's winter currently. Okay, everyone tell me this time is AI's spring. And yeah, after the spring, I will present some models, some applications we conducted in Tencent. Okay, so the title of my presentation is Advanced Technology. This technology is almost in foundation model and the industrial applications at Tencent of multimodal generative model. Okay, because I'm a multimodal guy, so I only present multimodal stuff. Okay, and yeah, so in my talk, I will present three kind of multimodal generative model from video generation, 3D generation, to image generation. And yeah, everyone ask me why you call your model as 混元. Okay, 混元 in ancient Chinese means a transitional process, moving from disorder to order, from chaos to regulations. So our mission at Tencent is to build very powerful and trustworthy models to handle massive multimodal data. Okay, and yeah, everyone knows it. It's Sora from OpenAI. So Sora is I think it's opened up a new era for video generations. You know, before Sora, almost video generation model just only can generate 4 second, 3 second, 2 second video. And Sora directly generate 1 minute video. Yeah. And OpenAI researchers claim their video generation model are word simulators. Okay. Such word simulators have three main features. The first feature is turning video data into space-time latent patch or latent code. Okay, and the second feature is scaling up the model. The model is diffusion transformer, also known as transformer-based diffusion model for video generation. And the last feature is some kind of semantic understanding for video, just for video labeling. Yeah. They apply the DALL-E 3 recaption technique to reach the caption, the raw caption, maybe very short, okay? After recaptioning, every video's caption is very rich, very long, and descriptive, okay? And the three features we implement, and we'll get some good result. I will present later, okay? And what is diffusion? Yeah, diffusion is the foremost one for video generation, image generation, 3D generations. So diffusion model is almost probabilistic model. Okay, this model actually is a process, a stochastic process. Okay, the process may be in diffusion process, maybe in Markov, non-Markov process. Okay, the goal of diffusion model is to achieve some kind of transformation between any two distributions, maybe one distribution from text, another from image or videos. Okay, so in this figure, let's see, toy example figure. Okay, I just draw a transformation between a very simple distribution, a single Gaussian, to another complex distributions like two Gaussian. Okay, maybe three Gaussian, maybe four Gaussian. Okay, and I use the blue arrow to denote the diffusion process. Yeah, the diffusion process means we move from real distribution to a single to a simple distribution like Gaussian. Okay, and the reward process of diffusion. Okay, the reward process, I use red arrow to represent. Okay, this process just convert a simple distribution like Gaussian to very complex distribution like image distribution. Okay, so we use forward process to do denoising, to do noising operation, and use reverse process to denoise operations. Okay, and I use X0 to represent the raw data, raw image data from complex distribution, and X1000 to represent white noise, white Gaussian. Okay, so for computer science researchers, forward process is very easy to implement. We just use some linear weighted to sum real data and noise. Okay, this is noising formula, very simple, very simple. Okay, X0 is the ground truth raw data, and epsilon is a drawn from white Gaussian. Okay, and the weight alpha is known by some design. Okay, this is a noising process, and then we want to reverse this process. Okay, how to reverse? This is a very hard problem. And we need to apply some advanced mathematics like ODE, like PDE, to derive such a reverse process. And one solution was given by UC Berkeley researchers, like this paper. Okay, and this solution is present a closed form solution, like this one. X t minus a is equal to some weighted difference between the last time x, xt, and some noise. Okay, the noise term can be learned by deep learning model. Okay, and all these weights are pre-specified. Okay, so our problem is how to specify the noise term. Okay, so diffusion model is applied transformer or convolution network to predict the noise. Okay, and in this formula, we have some hyperparameters like time step, like condition, like interval step. Okay, when the interval step is equal to 1, the reverse process is Markov. Okay, if A is greater than 1, the reverse process is not Markov. Okay. So the problem is how to estimate the noise prediction network, like this flow chart. Okay, our training process is quite simple because our objective for learning is simple. How simple? Okay, we simulate input. The input is xt. Xt is a noisy image. The noisy image is made by summing a ground truth image x0 and some known noise epsilon. Okay, and then the hyperparameter t, as I said, hyperparameter t is due specification to the weight. If t is 1, then we'll get alpha 1. If t is 300, we'll get alpha 300. Okay. Now the input is known, and the output is also known. Output is noise. Because we want to reduce the noise, so we want to build a model, the neural network model, to end-to-end, to learn from input to output. Input is noise data, output is denoise data. Okay. And then we want to know what is the architecture for the noise prediction network. Previously, there is a well-known work, Stable Diffusion. Okay, if someone knows some about generative AI or computer vision, SD is very well known. It's a UK company. Stable Diffusion. The Stable Diffusion backbone network is actually convolution neural network. Okay, I have to do this one. And last years, one paper replaced the convolution network architecture to transformer. And this method is called DIT, also very well known. And the DIT is the basic model for currently almost all image generation model and video generation model. So we move to DIT. And the DIT is for video. We propose space-time DIT, like this one. And I have drawn an inference process. The inference process means, okay, giving time, a dim text prompt, and white noise, and we apply STDIT and apply a decoder to yield recovered high-resolution videos like this. Okay, so we have two modules. One module is SDDIT, another is a decoder. Okay, and SDIT is very hard to learn. I will propose later. We first talk about decoder. The decoder is video compression network decoder. Decoder is due to an encoder. So how to learn encoder decoder? Because we want to recover video. Why? Because video is very large. It's too large to fit our GPU. So OpenEye propose we do some kind of reduction, dimension reduction. Okay, we reduce high dimension video to latent ones. Latent ones is called some kind of latent embedding or video embedding. Okay, after reduction, we want to recover because the ultimate goal is to recover the high resolution, high fidelity video. So we have two modules, encoder and decoder. And these two encoder decoder are in the same architectures. The architecture may be convolution neural network, maybe transformer. Actually, we tried both and find convolution network plus temporal transformer work best. Okay. And how to use the encoder? Okay. Actually, we use it in training. In training, we convert all raw videos by encoder to latent embeddings, and we just load the latent embedding to memory. Okay. And at inference, okay, after apply SDDIT, we get video embedding, and then we apply a decoder to recover the high resolution videos. So this is all like this one. First SDIT and then decoder. Okay. So this is the most important stuff in video generation. So I call it a superior space-time DIT because it's very hard to train. Why very hard to train? Because, you know, for 5 seconds and 500 pixel resolution videos, we get over 20,000 video tokens. This is very large, even for large language model. Okay, and now we do video generations. Okay, we have to save many intermediate results in memory. That is very hard, even harder than large language model. So that's why only OpenAI first trained great video generation model, and the Google Meta didn't do that. Okay, because very challenging. And in our architectures, okay, the model architectures is by stacking lot of transformer blocks, 20 blocks, 30 blocks. Okay, and the input is text or some prior knowledge, 3D or time. I call it head tokens. And the bottom tokens is the video generation result, we call video embedding. All our tokens are fed to the model architectures of DIT. And the one step, we reduce noise once. And after a lot of time step, we reduce a lot of time. For example, in this slide, we just gave 3 time steps. After 3 time steps, we get a good video from noise, from totally white noise. So I imagine this process, space-time DIT, as peeling off an onion layer by layer. Yeah, maybe 1,000 layers, maybe 3 layers. Okay, so this is all process. We diffusion noise to get high resolution videos. Okay, if your video is longer, then the transformer need more tokens, and the tokens the length scale up. The square in the square complexity of the input length. That means we have 1,000 tokens. We need 1,000 square time complexity and space complexity to train this model. So it's very hard. Even we have 1 million tokens for one video. It's very hard to train. And lately, I think maybe OpenAI also face the same problem to train long sequence. Okay. So this is the result by our first foundation model. I call it a Tech2 video model. And all these 3 videos in 1,000 pixel resolution. And the time duration is in 8 seconds to 16 seconds. Okay, this is our first model. Our second model is text plus image to video. That means we have 2 kinds of prompt. One is image, one is text prompt. The image may be some from product image, from advertising image. Okay. And the third foundation model is image to video. Use image prompt solely. Okay, the first frame of the last two videos is from the image prompt. Okay, given this foundation model, we can do a lot of applied model. So we call it X, 4 plus X. We have 4 foundation model: text to video, image to video, text image to video, and video to video. And apply them in our combination, in a proper combination. We can give you a lot of downstream applied model like video stylization, video editing, portrait animation. So this is for examples from video stylization. Currently, Tencent Cloud provides this service. All video stylization techniques is in real time. That means we have 3-second video, and the latest time is also 3 seconds. And we also have motion brush. For any image, okay, you touch some region, and we can make this region moving like this bird. And also we have a pose-guided video. We can make this pose to move like a video. Sorry, I cannot play it. Let's just act a video. Okay, and we can input 3 people and 1 people and an animal, and more people, more animal, and we can make all dancing, given to a post video. And the last one is video rejoin. We can change the screen from wide to short, from short to wide, and also in real time. Okay, this technique is all sold out in Tencent Cloud. Okay. The third model is a Hunyuan 3D generation model. The 3D is hard, and in recent years, 3D generation is more and more popular. Just in 1 month or 3 months ago, we have 2 great works. One is from Shanghai Tech University. This is the award paper from SIGGRAPH this year. Another one is from Meta 3D generation. And the goal is to transform textual descriptions to detailed 3D asset. And we have a Tencent 3D asset. And now how to build a good model to transform the text prompt to useful 3D asset. This is open problem. And the techniques is also very hard. Okay, I have discussed in video generation, we need encoder, decoder, and diffusion. And for 3D, we did the same, but we have a more complex pipeline. The pipeline is, this is the pipeline. We have at least 5 components in this pipeline. Okay, the input is text prompt or image prompt, or text and image prompt. The output is a generative 3D mesh. Okay, and firstly, we usually do multi-view diffusion. Okay, multi-view diffusion is image diffusion. We get several image sequences, and then we pass it to 3D transformer to get 3D constructors. And then we do 3D super resolutions. And lastly, we do 3D mesh refinement to get 4K 3D asset. Okay, and luckily, the whole pipeline costs very few time, and currently we can do half a minute to generate 3D asset. And this is, for example, half a minute. Okay, from game props, e-commerce good, and some 3D, some cartoon characters and others like some mapping and some example toy. Okay. This is for text prompt, and for image prompt, in industrial application, image prompt is more popular because users don't want to input good prompt, and users don't know how to input good prompt. And then, okay, you just input the image, your image toy image. And we find we even get faster generation in second, from half a minute to several seconds, from text prompt to image prompt. Okay. And the last one is image generation model. And in 2 months ago, we open source this model's basic version. The basic version is in 1.5 billion parameters. Okay. This is the pipeline of our open source text-to-image model. The first module is multimodal large language model, and this module accounts for multi-round dialogue. The second module is DIT, image DIT, okay, or space DIT. And the third module is super resolutions. Actually, we can do 4K, even to 8K resolution image generations. Because the image is just one frame, not video. Okay, currently we just only can do 1K thousand resolution video generation. But for image, we can do 8K. Okay, and our image generation model covers main 4 features like good semantic understanding, especially understand Chinese, Chinese poet and the Chinese phrase. And we have very high quality. I have said we can do 8K thousand resolution, and we can especially support multi-round dialogue. At this time, our model is the first one. It's the only one in Chinese company to support multi-dialogue image editing, and it's totally free. Everyone can search Yuanbao app in your app shopping, or you can search in mini program in WeChat, search Hunyuan. Okay, all our image generations capabilities are there, totally free. No limit. You can try 3,000 prompt one day. Okay, and okay, from text prompt to image prompt, we found the image to image generation, not image prompt, is more popular for consumer customers like our ads customers. Okay, they don't want to write any prompt. They just give an image. We can generate more image from this one, 1 to more image generation, or we can move some particular object to new scene, like this prompt in the desert. We place this animal to a desert, and even we can put any like some glass, like some sneakers in Eiffel Tower or in Great Walls. That means okay, an image and a good prompt, you can make image to any locations as you want. Okay. So this is all example by our Hunyuan generation image model. And yeah, the first feature is we do subject attribute very good. Even we can do multi-subject, multiple people, and the people and the animal, very good. And we especially focus on Asian scenarios. So in our model, firstly, if you don't specify any race, we automatically generate Asian figures like this. And we needed to understand Chinese elements, some Wu Zhen, some like Niao Chao, and like Guangzhou Ta, and then like some poet, Chinese poet. Okay, the last part of my talk is to explore some useful industrial applications. Okay, so this is our built autonomous and controllable full stack technology from bottom to higher layer. The bottom layer is infrastructures. Okay, our infrastructures can support high-speed network interconnections. Actually, now our single clusters scale up to 100,000 GPU. Okay, 100,000 is very big, but not all. Well, H100. Okay, we have some low-end GPUs like H20 and R100 and R4 and so on. Okay, and the third layer is our machine learning framework. We support inference, very fast inference, and we support distribution and parallel training. Okay, and the high level is the model level. The model level we do support single output model and up to MOE models. The MOE model is in 1 trillion parameters, and the single output we support 1 billion, 4 billion, 7 billion, and 13 billion. And all these models have been open source within Tencent. Okay, and in one slide, we want to summarize our Hunyuan large foundation model features and the key capabilities. The feature is, okay, our pro version is in over 1 trillion parameters, okay? And our models can support very long context, up to 100 million tokens. And our tokens is very large, just text tokens. All text tokens is comparable to the total national public library collection, okay? And our 4 key capabilities, I summarize like 4, okay? Actually, we have more, but I think the four capability is the most important. The first is powerful Chinese language skill. The second is logical reasoning skill in complex context. Why we add complex context? Okay, every language model can do simple reason, but if you put that in very complex scenario, very complex context, such as the first prompt just do English Chinese translation, and the second prompt is do math problem, and the third prompt is do code problem. This I call it very complex context, and we want to check in such complex context how your reasoning do well. Okay, actually we do very well in this complex context. Okay, and the third feature is we can deliver reliable instruction following, like we can read online web page, online PDF, offline PDF, and in very large quantity because we have supported long context window. Okay, and the last day I just tried. I put 10 PDF papers and 10 web pages, and we want our language model to give a good summarization. It do pretty well. Okay, I suggest everyone to try it. It's totally free. And the last capability is we can do very excellent multimodal understanding and generations. Okay. So currently our foundation model support over 700 products and services within Tencent, like very well-known product WeChat search, and the Tencent Meeting, Tencent Document, and the Tencent Advertising, and the Tencent News, and Tencent Video. Okay. So in my view, I think the future of software is generative. So in Tencent, we embrace generative AI as soon as possible, as early as possible, as wide as possible. And yeah, the last, I think the last slide is show some example for our video AI GC. Yeah, we generated promotional video for over 20 Chinese medias. And this video example is for People's Daily. The first half is generative. The last half is real. So, okay. So we almost complete our talk. And if you forget all my previous content, that's okay. I just want you to realize my thought at this slide. So this slide talk about two paradigms of generative AI in my opinion. Okay, the first paradigm is GPT. Okay, GPT's backbone network is directional transformers, and its learning objective is net token predictions, and its learning theory is to compress word knowledge. Okay, by enforcing scaling law, your model is bigger and bigger, larger and larger, wider and wider. Then this GPT model, this large language model, can be seen as a words reasoner. Okay, as for diffusion model, the backbone is bidirectional transformers. The learning objective is to do noise predictions. And the learning theory is transform probability distributions. Okay, you know, diffusion is very, very useful, not only for computer science, but for general science like math, like physics, and biology. You know, AlphaFold 3 just use transformation, just use diffusion to transform distribution between different kind of structures. So we can not only to transform distribution from noise to meme to video, we can transform any kind of distributions. if you have a large data for these two kind of transformations. Okay, so by enforcing scaling law, okay, I think the diffusion model can be seen as a word simulator, like Sora does. Okay, and maybe you have three more paradigm, but currently we just try GPT and diffusions. And maybe the third paradigm is a mixture of GPT and diffusion. The mixture means some kind of transformer, some layers. We just use bidirectional, and some layer we use bidirectionals. And the learning object, we can do a mixture of noise prediction and auto regressions. And that is some research are doing now. Okay, and thank you for attending.
We are honored to have with us another distinguished keynote speaker who has made remarkable contributions to the field of natural language processing and AI. Please welcome Dr. Xiaodong He from Jingdong to the stage.
So use this control. So how so excuse me, so how control this use this one? Yes. So first, thank you for inviting me to come here. I'm really glad to have this opportunity to exchange some of our ideas and some of our progress in using AI to do generative content, and also how we can apply this technology in the industry scale to really put this technology in the hands of every single user in the world. So we all know that generative AI is really, I would say, really hot. It's a really hot topic. And actually, Dr. Wei Liu just gave a good presentation how in Tencent, Hunyuan, the large model can do a lot of generation things. And if you look back at the society, we can also see that there's many generative models which are giving very close to human or even close to profession generation results. For example, in speech, in text, or even in image and video. Here's a simple example. Look at, I would say, because the resolution of the picture somehow is not as high as I expected. But look at the picture in the right-hand side. So in the timeline, we can see since like 2022 or 2023, the gap between the professions generated content and the AI generated content are very close. It's close to zero. That means the AI can generate content that are so high quality that it cannot be distinguished from profession generation. That means the AI's generation, actually the content generated by AI, are ready to be useful or even valuable in terms of business usage. And of course, this not come in one day. We know actually because of the large language model or even large model, we now can have an AI model that can generate such a high quality content. Look back, we can see that since almost 10 years ago, we start to use neural network model to model the semantics of the language that can be viewed as a starting point of the language model or even large model. That's called word embedding, or at that time it's called word to vect. That's back to 2013. And then there's another big leap. Leap is the attention model, which is invented by kind of like a group of scholars in Montreal, University of Montreal, called attention. Now this attention model extremely extend the ability of the model to handle long span information, especially for text. Further, on top of the attention model, people invent the transformer. I mean, the paper have a famous name. It's called "Attention is All You Need," which is published by a group of Google scholars in 2017. And on top of that, people built BERT and the GPT, which reached another milestone in 2020, which is GPT-3. That's the first time actually people build a model have a parameters more than 1,750 billion, I would say, yes. Actually, it's 175 billion parameters at that time. That is so far the biggest model people ever built in the neural network field. That gave a very impressive output, very impressive results. At that time, people see the model can generate a story, long story, very reasonable, very fluent, just like human generated. And on top of that, people further take another 2 years. OpenAI take 2 years to convert or improve GPT-3 to ChatGPT, which means add the chat ability to the GPT-3. So the model can interact with human to take humans' deep request, understand people's deep intent, and generate the content people really ask for. So that is for language. And meanwhile, there's actually another trend in image or in vision. Start from image generation in 2014, which is GAN was invented at that time, Generative Adversarial Network. And later, also people put an attention mechanism on top of GAN, like attention GAN, which we published in 2018, to make the image generation much more accurate and with high resolution. And later, diffusion model is invented to push the level of the image generation quality to a new level. And later, there's a diffusion transformer and get to the Sora, which everybody knows today, published in early this year. I think my colleague Liu Wei actually just gave a clip of Sora's output just minutes ago. So in this sense, we can see after like almost 10 years of continue improving, we are at a stage that today AI can generate really high quality content. But looking forward, what we really want to do, what we really want to go from language to a more broad range of content is the problem we are facing. So look forward, we actually at a, we'll say we are at age of large model, but we are also moving from language large model to other fields, like we're moving from language intelligence to multimodal intelligence. As I show some of the example, when we say multimodal, that means our model just don't just process one single modality like text or vision. We actually can mix them together, just like a human. We have eyes, we also can read text, but also can handle the vision signal position, the vision signal as well. In a sense, we now can ask AI to do image generation given very detailed description in text. We can even align or reasoning over the picture content given the language request. So that's what we call the multimodal intelligence. And also, multimodal intelligence is also greatly improved thanks to the large model foundation. Moving forward, actually, at least in JD, we're looking at embodied intelligence because we're thinking if we can put this high-level large model, its ability, the conditional ability to robotics, to the mechanics in the real world, we hope our mechanics can also do more smart activity to finish a more challenging tasks for our human. So that's kind of the trend of the large language model. And looking in details, we'll talk about multimodal intelligence first. So when we talk about multimodal intelligence, we'll talk about actually three things. The basic thing is alignment. Because when we talk the intelligent process of the signal between different modalities, one of the fundamental problems is how to align them, how to align the content, how to align the information, the semantics in one modality to another. For example, between text and image. In one of our papers published in 2018, laid one of the framework which are, I would say, quite widely used today. So to align the semantic content between image and text. In that sense, we actually propose a bottom-up and top-down attention mechanism, just like kind of like how human put our attention on the image or on the vision signals. We actually focus on the object in the image and developed a bottom-up and top-down attention mechanism computed in this way, such that we can greatly improve the alignment accuracy between text and image. Later, we further improve this method, actually, which is another paper we published last year, to do alignment more clearly or more precisely between the text semantics and the segmentation rather than box. So in this time, we actually try to align between the text information to the pixel level segmentation information in the vision. In this sense, we can have a much more precise alignment. Of course, this presents a lot of challenge here because when we do the pixel level alignment, then the boundary or segmentation boundary is actually a major challenge. In this sense, actually, we try to we propose our called seg clip. In this sense, we try to define a set of learnable center. Basically, can be viewed as a quantization of the image patch. In this sense, we try to utilize learnable centers to cluster image patches when we train an image text model with a pre-trained large weights to address this zero-shot semantic segmentation problem in open domain. By doing that, actually, we can achieve much better semantic segmentation results given the text request. In our experiments, which we published in also last year, we can see actually we outperform the previous baseline significantly. Moving from the static image to video present another problem. Think of there's one of the questions we are facing. So giving a set of long video, and if you ask the machine looking for a clip in this video for particular content, this means this AI have to do some searching, even reasoning to locate the particular content that you are asking for, and even locate the particular object you're asking for. This is an example. For example, from the clip including, we just want to exactly clip that contains a child in dark green rides a red bicycle among a long span of videos. In a sense, means we want a result both temporally give the boundary and spatially give the region. That's actually that's almost a 3D problem, including the 2D picture and another one dimension, which is time. In this video scenario, we are facing actually a lot of problems. One of the major problems is how we get a lot of labels. When we train a model, usually we need a lot of label, but for a video, that means we need to label every frame in this video to provide the annotation to train the model, which is really very prohibitively expensive to do the actual labeling. Of course, another problem is how we learn the multi-model representation between these two modalities, between video and the text, which also is very computationally costly. In this sense, actually, we propose two major ideas, which is just published this year. One is the single frame supervision. We don't label the video, actually, we label the key frames in the label. That means that we save at least two magnitude of time, 2 times of magnitude of the labels of work. So we can greatly improve the annotation process. Another one is we propose a two-stage multiple instance learning-based framework. Limit of the time, I probably will skip some of the details. Basically, we try to use query aggregation transformer and with a curriculum designed learning, with a carefully designed learning to directly model the multi-model features. In that sense, we can have much better representation learning and also enforce our model performance in terms of this video question answering to give a much better results compared to other state-of-the-art. So moving forward, actually, we are getting to the generation part. So eventually, we hope the machine can generate content for us. As we show at the very beginning, we now believe AI can generate very professionally high-quality content and for business use. In here, I pick one topic, which is human generation, or like digital human generation. In this one, because we think human probably is the most valuable content, especially in our business model. But also, this presents a lot of challenges because as a user, as human, we are so sensitive to any distortion of the human presentation. So this gives an example. So let me give a quick introduction of the overall framework. At the right-hand side is the encoding part. So when we train the model, we basically do an encoding process. We encode the image, we encode the video information, we encode the text, we even encode the audio and the 3D motion of the human. And hopefully we will build our model and we will do some intermediate representation or hidden representation thanks to the neural network. Then we output the generated human. But then there's quite a few things we want to a vote. For example, there's some common problems we show here. For example, in the second one example in the right-hand side, actually, in your case, it's, in your right-hand side, the appearance inconsistency. You can see the baseline model when they generate the human, and when the human make a pose change, actually the face also changed to another people, which is not acceptable. And also there's another called human deformation. So when the human do some pose, if you notice well, actually there's 6 fingers, there's 5 in the right-hand side. And also the third one is movement unreasonable. When David tries to drink the beer, actually there's some very unnatural move for the human. And what we want actually is, if we really want this be useful for the business, we actually want to have this close to 0 hallucination rather than have this flaws. So this actually presents the major challenge: how to make a long enough human video and there's have almost no hallucination, so our user don't even notice this is generated by AI and it's generated by natural, actually by hopefully by natural profession. This is the goal we want to achieve. Limited by time, I will skip some of the details, but this is actually not just a science problem, it's also involved a lot of engineering as well. But eventually I will show you some output. So first give you some example how we build the, I would say close to 0 hallucination digital human example here.
成为了业界热议的焦点。首先，何博士能为我们简要介绍一下 ChatGPT 是什么吗？
当然可以。ChatGPT 是一种基于 GPT 模型的人工智能，它是由 OpenAI 团队开发的，旨在实现与人类类似的对话和文本生成能力。ChatGPT 能够理解自然语言，进行智能回应，并在各种场景中提供协助，如客户服务、教育、娱乐等。
So this clip actually demonstrates 2 digital humans. One is the avatar of myself, another is my assistant. So you can see in the virtual cyberspace, these 2 virtual humans can talk to each other. And then this was actually produced last year. In this year, we further improved the technology, make it more, I would say, more expressible, less hallucination. And now it's totally ready for the business use. Let me show the example.
在《三国演义》里，为了心中的理想主义，有知其不可为而为之的孔明，有至死绝不放低内在坚持的成功。他们虽然没能实现大团圆，但他们的坚持和执着，真的让我们感受到了理想主义的浪漫，让我们的心灵受到了极大的震撼。再来说说。
So in this example, actually, that's what we produced a few months ago. We produced a digital avatar of Richard Liu, the founder of JD.com. In that sense, actually, we polished every single detail to make sure this avatar can very precisely reflect Richard Liu's his own habit, his own expression, his own gestures. So make it look very real. In that sense, we actually make a big test. We put this live stream broadcast for sales online for almost 1 hour. So in a whole 1 hour long span, the whole generated digital human almost didn't make any problem, and more than 20 million users actually watched this video, and they gave a lot of comments. Most of them are actually very positive. That means actually people are start to accept this kind of AI generated content. Really don't feel there's a difference between real human and actually digital human. And actually people place an order more than, I would say, 50 million yuan of orders to really buy the book, buy the plans, actually, which Liu as an avatar actually introduced. So future, in the next step, we can even more practice to the industry scale. When we say industry scale, we mean probably there's hundreds of millions actually start to use it. Hundreds of millions of people really to watch this, to interact with this avatar, to actually even ask questions and get answers here. For example, we make an avatar for Dong Mingzhu, which is another famous figure in China.
企业如何发展，也让我们在这个过程当中体会到品牌的价值。
So if
我们
people
格力
know
认
Dong
为
Mingzhu, you
品
can
牌
probably
就是用
tell.
质量、技术、担当、责任来支撑 那么现在是一个大数据时代，我觉得我们就用数字说话。
So even beyond that, actually, we can even open some new opportunities. For example, we can ask some foreigners to speak Chinese, because this is another example. The second guy, actually, he is the president of LG Korea. He really wants to talk to his customer in China because he sells so many LG products in China, but he cannot speak Chinese, unfortunately. So we make an avatar for him. Now he can speak Chinese to his customer in China now.
喜欢玩游戏的朋友应该都知道，不同类型的游戏对显示器的分辨率和刷新率要求都是不同的。游玩画质精美的3A 大作，或者在虚拟世界赛车竞速时，是更依赖超高分辨率。
And we can even ask a guy from Brazil to
绝对是老字号中的老大
to even
哥。
sell some
自打1436
Chinese
年
food.
，6B 居在京城创业，保卫岛就在咱们吃货嘴里扎下了根。联名朝内歌手傅岩松也是他的粉丝，曾特意为6B 居题写牌匾，那3个大字现在还在大石栏总店的门头上挂着呢。听说为了送菜方便，清皇宫还特意赐给6B 居一件黄马褂和一顶红缨帽，真是盖了帽了。6B 居是京城出了名的酱菜园。
And we can even open some new activities between different avatars as well.
我看
So
到
let's
刚
open
刚有
many
粉丝在
business
问
opportunities
牛
as
皮
well.
适合用什么，我现在来回答一下这位粉丝。牛皮可以试试我们的基底精华液平衡水、速修精华油平衡霜，都是非常好用的，舒缓肌肤，改善水油平衡，维稳肌肤，质地清爽不粘腻。
So in the last stage, I will say actually show some of you, show some of our progress in embodied AI with you. So probably limited time, I will skip the technical details and just show you some example. So when we say embodied AI, actually that's a broad understanding of what is embodied AI. So a simple case is like we build a mechanical arm. For example, in JD, we use mechanical arm to do this logistics. But that one is very programmed. So the itself don't have many cognition ability. But future, actually, we hope the machine can do really complicated tasks for us. Let's show this example. For example, this is a service robotics, which is working in our dining room. So this one involves a lot of, I would say, detailed operation and controlled operation in a real world scenario. Yeah, and by making machine have this kind of ability, we can imagine it. That's a bright future that our robot can do a lot of things for us. Yeah. So that's pretty much what I want to report. Thank you.
Now we move on to the exciting part of our evening panel session. We are privileged to have an esteemed panel of experts from academia and industry, sharing their diverse perspective on the computer science. Leading this discussion is our outstanding host, Professor Yunhao Liu from Tsinghua University. Professor Liu is a renowned scholar in computer science, known for his significant contributions to various sensor networks and cyber physical systems. Let's welcome Professor Liu to host the panel.
Okay, thank you so much for your kind invitation. I'm very excited today to join this very important conference. As well, this is the first time I came here, and it's so beautiful, such a great place. So yeah, we have already listened to two very interesting talk. So now we are going to start our 45 minutes panel discussion. I think this is the most important panel I ever chaired. So the panelists are so distinguished. So first of all, let's invite Professor Shin Tong Yao. Well, yeah, please have your seat. So, well, I don't know whether we should introduce details, but let me read. Fields medalist, member of the United States National Academy of Sciences, and also the American Academy of Arts and Sciences, foreign member of the Chinese Academy of Sciences, and chair professor at Tsinghua University. So basically, my colleague, but it's much higher level than us. So welcome. Also, I'm going to invite Professor Leslie Valiant, the ACM Turing Award laureate, also the member of the United States National Academy of Sciences, and also the fellow of the Royal Society, professor at Harvard University. Thank you. Now I invite Dr. Wei Liu. He just delivered a very wonderful keynote speech 20 minutes ago. Dr. Liu. Dr. Liu is the Distinguished Scientist of Tencent and also IEEE and IAPR Fellow. So welcome. And Professor Dr. He Xiaodong. He just also delivered the keynote speech 5 minutes ago. So, distinguished scientist at Tencent and the fellow of IEEE and IAPR. We also have distinguished speaker from far away, Professor Mao Tiyong. Mao Tiyong, please come to join us. He is the distinguished research scientist at Google and also member of the American Academy of Arts and Sciences, fellow of ACM and fellow of IEEE, ICAR, and EATCS, ETAX. And also he is an adjunct professor at Columbia University. So thank you, welcome. And last but not the least, Dr. Tianyan Liu. This is my academy brother in my department. He is distinguished scientist at Microsoft Research, AI for Science, and also the fellow of IEEE, as well as fellow of ACM and fellow of AAIA. So thank you so much. Well, today's talk, I just realized the topic today is the evening of computer science. So I talked with Dr. Liu and we exchanged ideas and we realized that we have a lot of different evenings, like evening of physics and the evening of computer science. So today is somehow focused on computer science. So, if you talk about anything about computer science, the most important hot topic is artificial intelligence. So although artificial intelligence, AI, include so many different disciplines, but computer science is clearly and obviously the most important field. It is highly related. So let me start from our discussion from a very general topic. I'm going to give each of the panelists a chance to talk about this. So generally, AI has so much different impacts to the society. So some people like it so much, and some people do not like it and even hate it. So in your mind, I'm going to give you the question. So in your mind, what is the most negative impact, and what is the most positive impact, or what is the most positive impact to the daily life or research or whatever in our fields or around you want to mention? Just one most important positive and negative impact you think. So let's start from somewhere. Maybe we start from some people do not speak anything yet. You give the opening speech and you deliver the keynote speech. So let's start from maybe in Chinese culture, we start from the farthest guest. So Mauti, maybe you start first.
Okay. It's easy for me to talk about the negative because lot of
Or
my
you can
research.
only speak on negative, or
No,
you
no,
only
not
can
only,
speak
not
on,
only.
on positive.
Not only, but I'll start with the negative because I think AI is great in doing many things without, not always with our understanding of it, but yet experimentally it performs quite well in many domains, and the talks showed it here. In the domain of video and picture generation and multimodal. And however, every technology that we put forth in computer science have been abused by the bad guy. And as a cryptographer and a security researcher, these things never let me sleep well at night, because I'm just waiting for it to be abused. So deep fake, the minute you improve your generation of believable objects, then the bad guys are going to generate something that you are going to believe, but it's going to be fake, and there will be implications. And at the beginning, they're going to do it for fun, and then they're going to get the economic incentive, which is the underlying thing behind the IT industry and the IT dark industry of the bad guys. And then we're going to say the C impact. So AI is great until attacks come. Even today, and I worked on it in the sense of contaminating the inputs and seeing the effect, but it can be abused in many other ways. And it's almost easy to predict, because the bigger the power of AI to do good things, the bigger the power of abusing it. The good thing of AI is that productivity is going to in areas unimaginable so far, things that people believe that it's due to human creativity are going to be formalized with as an AI problem, and AI is going to experimentally solve most of it. And experimentally, I mean the things that I'm not satisfied with, that there is no explanation, there is no formal calculus that I can say it's doing it right, but it's going to do it statistically most of the time.
Okay, thank you so much. I think what do you think is kind of people worry the AI is somehow we don't understand and they might be out of our control, or it's going to go somewhere. It's not what we imagine or not we planned for it, right? Okay, well, let's listen to other people's thoughts. Thank you so much. Kaya, maybe you talk, you agree or not agree?
Let me share some of my personal
okay,
opinion, yeah.
Go ahead.
So first of all, talking about the positive impact of AI, I think these days AI are actually making transformational changes in many real industry. I think that is one thing I can see very important. AI is not a toy. It's not just something we do research for, but really something transforming our life and our industry. I think today Wei and Xiaodong introduced a lot of good examples how AIGC have been widely used in their companies. And from Microsoft, I'm working on AI for science, and speaking from my position, I also see a lot of opportunities of using AI to disrupt for example, pharmaceutical company industry, the chemistry industry, material industry. Those are really fundamental. So that's a very positive aspect of AI today. And talking about the negative part, I don't really want to repeat, AI can do evil, something like that. But I see something maybe not very good for the research community, for people in this room, because today, the major research paradigm for AI is something like scaling is all you need. And seems that the intelligence or smart mind is no longer needed. And there's a kind of a beta license. So if you put out of data and compute there, then the intelligence will emerge. But traditionally, our researchers, all the great scientists in this room, we actually have done a lot of great explorations to see whether there is something very special behind the intelligence. But it seems today that are not very encouraged in many ways, because if you do not have many machines, GPUs, you cannot really make the world pay attention to your work. And furthermore, I think today's AI is not very sustainable, environmental sustainable. So for example, using 100K GPUs to just train a big model, and human just use one egg, we can do the same thing. So is this really a good computational paradigm? Is really something that worth that kind of investment? Let's suppose one day you really have a great AI, AGI from the computer, but it will cost, the training of that will cost 1/3 of a company like Microsoft. Does that really make sense? Yeah. So those things are really something in my mind.
Okay, so after I listen to your points, I feel that all you said are actually very positive. So the points are which are not positive, I think it is only some challenges and to push us to go forward. Well, okay, this is one kind of a very good aspect. So Leslie.
Okay, so yes, I think the subject is difficult because I think AI is something which will get into all aspects of our lives. So it's like a comprehensive all our problems. And so basically, I think AI magnifies the power and magnifies our power in many different dimensions, and magnifies our opportunities and also the dangers. But I think many of the issues AI will get into are very familiar ones, so that they're not new problems. So for example, just to raise another issue, is people discuss fairness. So will AI make fair decisions about people? But of course, this is an old problem, that unfair decisions have been made about people for a long time. So I think AI almost raises our game. It makes us think about the problem more carefully, about what is fair and what isn't. So I think so I feel very positive about AI. So clearly the dangers are there because our powers are increased, but also it drives us to examine more carefully what we do.
Okay, so I hear one word, dangers. So let me ask you a further question. Last week, I actually interviewed Manuel and Lenore Blum, and I asked him one question because 2 years ago he has a paper, consciousness theoretical Turing machine. So let me ask you this very simple question: do you believe AI is going to have consciousness or something like that? Consciousness.
Current AI.
I mean, in the future, whatever, 20 years, 50 years, or even 100 years, whether AI is going to have its own consciousness. Well, I'm going to tell you his answer after you answer this question.
So I am familiar with their approach. As far as my outlook, I don't think consciousness is a well-defined notion. I don't think people agree on what consciousness is. So in some senses in which they talk about it, they define it as not being an issue. But I think I haven't found consciousness to be a useful concept in discussing AI.
Okay, I tell you his answer. He said, yes, there will be, and this is a must. And I asked him how long. He said maybe 50 years or within 50 years, or the longest will be 500 years. So my further question is, how long we do? He said there is a discussion about how long we will destroy ourselves by AI. Well, so what is your idea on that?
Whether we will destroy ourselves by AI?
If they have consciousness, so obviously.
No, I disagree. I mean, we can destroy ourselves in many different ways other than AI. And whenever we have dangerous new technologies, we have to develop methods of somehow staying in control and not indulging in risky behavior. So I think with AI, the main issue is who's in control? Are we in control, or are the machines in control? So this idea that machines will necessarily seize control from us, I don't see that argument. I don't think that has to happen.
Yes, I agree with you. So every time there is very new technology emerges, people will worry whether we are going to be destroyed by this new technology, even electricity and the all this kind of new technology. Let's talk about it later offline. Professor Yao?
Well, first of all, I'm not really a computer scientist.
Well, that's fine.
Although I did make some contributions sometimes. Well, I'm an optimistic person. I always like to see anything that are useful should be encouraged. It's clear that AI has done something good and should be encouraged, especially when I see that AI can do computation in very high dimension than what we can do. And that's something one need to understand why it works in that way. There are many other things that I think they are useful. But I think, on the other hand, we are too optimistic about what AI can do in general. Let's say we are very interested to see whether AI can do much for science or for mathematics. I think that will be exciting to see many things. But on the other hand, let's just be objective. From my point of view, objective. So it's objective too. We saw two of our great lifetime awards in mathematics, Andrew Weiss and also Hamilton. They did their great work about 30 to 40 years ago. One on Fermat's theorem, which actually Taniyama wave similar conjecture. One is Hamilton's work on Ricci flow. These are two spectacular work in the history of mathematics. This was done in 1980s, leading to early year 2000, but I think majorly largely accomplished at that time. Well, I think they may get a little bit help from computer, but practically none. This kind of work is spectacular, and I look at what we have done in the last 10 years. I don't think we have anything that can measure up to this great achievement, at least up to now that I know. So what it means is that computer can help, but it need not help us to accomplish what was done in the history of mathematics or history of science. And this something means that it doesn't mean that AI could not help, but on the other hand, we still need to exploit a lot more power from AI to get this achievement. The intelligence that was accumulated by human are still much more powerful, despite of many exaggerations by Te Tao and many other things. I actually asked Manford, who is very much a fan for computer and all that. He was a great algebraic geometer, one of the very major one. And then he changed to computer graphics, as you know, and did very good work. So I asked him whether science, or in particular mathematics, has improved over the years since computer was invented. He agreed that it didn't make that much difference. Actually, it's not clear they have actually helped in a very essential manner. So what I'm trying to say is that we are very happy to see AI and all this computer helping in many ways. They have many more power to do computation to the very detailed extent. We see examples, curves of the seals of Riemann zeta function, beautifully distributed and all that. They are very good. They probably contribute something to our intelligent activity, but not as essential as what we had so far. So this is my my observation, which may be wrong, but I think we still long way to go. But I look at what people has been doing. I think, on the contrary, mathematics can contribute a lot to what people are doing, AI and all that. For one thing, I personally feel that the huge amount of computation and huge number of parameters was involved is partially because the whole subject is too linear, or using matrix calculation. But the whole subject is actually intrinsically nonlinear, which people in computer science has not explored, the nonlinear theory, which I advise people to go ahead to learn more nonlinear theory, which presumably will cut down the number of parameters. That's from technical point of view, that's my view. Now, besides that, it sounds very discouraging, but actually I'm very excited about trying to do AI myself and trying to learn. But there's another observation I'd like to make. Now that AI is more popular, AI GTP and all this, ChatGTP, all the students are now trying to use ChatGTP to do homework, to do exercise, and to write letters. Soon we will find that most of the students are no more that active in their thinking. And soon we will see many people are not thinking anymore. And then we will see that people are getting more brain disease because you don't stimulate your thinking. And this actually will create negative problem in the society. People are retiring early here in China, 55 or 60. And if many of them, high percentage are getting brain disease, there will be a terrible burden on the society. That is one thing I think, something that I think the government has not thought too much into yet, whether it will create more brain disease by not thinking in a global way. And I think there should be AI to be useful. One should help to stimulate thinkings of human beings or the people in the society. I think this is very important. Besides the fact AI probably would be certainly used in fighting a battle and could destroy a lot of people. But anyway, these are something I worry about. Thank you.
Okay, so Professor, you all think the AI and computer technologies do not contribute too much on how we understand this world and how the science going forward. Well, let me ask.
What I'm saying is in the future there should be much more.
Yes, but not yet.
Right
oh, yes. Yeah, not yet. Well, my question is, okay, so I hear some saying about the AI has 3 different levels of the functions in the future. Number 1, become the computational scientific microscope to let people see something which are not seen before. For example, in the playing chess, the goals, and some of the techniques we never used in the past, and now we know they are very good technique in Go because AI used that and beat people. So second level is to become the source of inspiration when you discover something or talk about something or think about something. Okay, third level is the most important. AI is going to become the agent of our understanding. Somehow they help us to understand something. Okay, let me ask you another question. For a long time, I want to ask some people like you. Do you think, or you tell us, is mathematics a discovery or our invention? I mean, human beings' invention.
Well, in a way, it's both. I mean, mathematics study objects which are far more extensive than what physics had. Physics thought about matters are only nature, but to us, abstract objects are also nature. Sphere, we look at it as a nature, but physicists thought that it was an abstract nonsense. It's just something to help to understand nature. So, we create interesting abstract objects, then we study it because they set up some rules, and those rules are important for us. And so the objects that we study are far beyond what people consider to be nature. Then the rules that appear in the society is an interesting mathematical object. So we create some rules, and of course you can say the rules exist in any case. But on the other hand, I think there's a lot of creation involved into there. So yes, also a discovery at the same time, a creation.
I ask this question because if somehow most of them are kind of invention, so we do not really get the scientific understanding. We actually get some scientific explanation on the issues or phenomena we observe, right? So we try to use that way to explain the phenomena. So someday they might be changed, or somehow the next observation might be different with what we have already observed, right? But that is, I'm thinking about whether AI can be, for example, can be the agent of real understanding about that, or they give another way to explain those of the things.
Well, let me explain to you, I mean, from my point of view. For example, I mentioned Andrew Weiss and Richard Hamilton just a few minutes ago. Well, Richard Hamilton created the concept of rigid flow, and that was not there before. And he created to understand many important concepts, which eventually lead to the proof of the Poincare conjecture. I consider that as a creation. It was not there before. But of course, internal logic, the logic is everywhere. You know, A implies B, B implies C, therefore A implies C. That, of course, is always has to be obeyed. You may say that that's not a creation. But to me, the interesting concept are difficult for AI or for computer to find. Let me take an example. For a long, long time, Chinese mathematicians did not accept the concept of imaginary number. I think Chinese mathematicians accept imaginary number only in 19th century. Before that, they did not like this concept because it looks bad. X squared plus 1 equals 0 should not have a solution. But, you know, during 15th century, people in the Western world started to accept it, and it developed it for almost 300 years. The mathematicians who developed it did not believe this number also, but they developed it nevertheless and becomes an important tool. And now, imaginary number is basically part of nature to us. I think no mathematician will consider imaginary number to be strange nowadays, but 300 years ago, including Euler, thought that imaginary number is a funny thing. They are not sure, although he invented the Euler formula, exponential I pi equal to -1. So this kind of concept, I don't think AI could produce. It's a brand new concept that doesn't exist in the nature or in any document before. Or some concept like quantum mechanics. Human beings still do not understand quantum mechanics thoroughly, so how would a machine understand it? So that's the kind of thing I think there's a limit to what AI can develop. Brand new concept that we never thought about before. The simplest one is asymmetric approach for plane geometry. We all learn Euclidean axioms. There are 5 axioms to explain many theorems. And each time when I go to AI, I challenge my AI friends to try to create axioms. So I give you, say, 300 theorems in plane geometry. Would the machine be able to produce 5 axioms for me to explain all this geometry? I think that would be tough. Or that is important. It's not just for abstract nonsense, because Newton, after all, when he wrote the famous book on mechanics, it was based on Euclidean thinking. It reduces every mechanical thinking to free motion, free equation, Newtonian axioms, right? So I think that's a fantastic major conceptual breakthrough, which I don't believe AI would be able to create. That's
well.
So in a way, it's a creation. That's why I said.
Thank you, thank you so much, Professor Yao. Maybe we invite Xiaodong.
Yes, actually, I hear many of my colleagues talk about AI and have shared a lot of interesting ideas. I would say I kind of agree with Professor Yao about that. Today's AI still lack of principle, I would say. I think we are kind of like in the pre-Newton stage, as Yao said. We are still probably, hopefully, in the near future or in the future, we'll have a set of principles to define the basics of AI. We are not there yet. So, frankly speaking, I mean, many of us are doing AI is more from the empirical way, even including the neural network. It's powerful. It's really powerful, and it's really huge scale, and it kind of do a lot of things. But still, I think we don't really understand the principle underneath it. So we are still doing some experimenting. We are doing a lot of observation. We hopefully one day, when we accumulate a lot of these experimental results, we can hopefully invent or found or discover the true theory behind that. But that said, it doesn't prevent AI to be useful nowadays, even for today's AI. I will show some of my story. In JD, actually, I'm also in charge of the intelligent customer service department. So kind of my job is to use AI to help the customer service representative to answer the questions our customer raised. When, for example, if you buy anything from JD, you have a chance to, for example, ask for a low price or return it or change the delivery to another address. There are tons of these questions, tons of these requests. If we ask a human to do that, I mean, that's what we do before. It takes a lot of effort, human effort to do that. AI, especially the chatbot, for example, chatbot can do a lot of this work for our customer and also kind of save the labor of our real people, customer representatives. So that's actually, I can see the true value. It happens, it saves a lot of effort, especially in this Liu Ba, I don't know how to present. It's like festival, the shopping festival days. There's huge traffic coming in, and if you don't want to wait along on the line, if you don't want to really talk to a real human customer representative, our AI actually can answer you, provide the answer, even the solution to you in a much more efficient way. So efficiency is the most important thing, and make AI is useful, even if it is not complete or even not fully mature yet. So I think from my point of view, AI is positive and create a lot of value. Of course, maybe people can challenge me, said, maybe AI costs a lot of the human customer representative lost their job. Some people actually challenge me on that. And I actually talked to many real customer service representatives. And I would say none of them actually takes customer service as a life career. So I feel less guilty. Yeah, because I still think AI actually, this is a really labor-intensive work, and I don't think people will work this for lifelong. And eventually, I hope machine will take all this job for us. I mean, work for us rather than as a human to serve me. Yeah. So in general, I think I'm positive, and even I'm still positive even for the principles of AI. I believe there must be something underneath, really can help machine, even help us to really do something smart and useful, right? Although today we don't discover, but I believe there must be someone, and we can find out. And that's one thing, in the last sentence, I will say that's one thing really interesting for AI, because this is very few of this example that we have more than 7 billion of real examples exist in the world, how intelligent machine looks like. But we still don't know how it works. Every single person is an example how intelligent machine looks like, but we just don't know how it works.
Okay, Xiaodong is quite positive on AI. Wait, yeah, go ahead.
And I want to talk about the relationship between human beings and AI. Yeah, So firstly, I think AI is a human being's invention. Yeah, for the most popular AI, generative AI or foundation model, okay, I don't think it's a new invention. Okay, what does foundation model or generative AI do? Yeah, it doesn't did anything new. It just reorganize and reorganize the knowledge, humans' knowledge, humans' observation, humans' signal, and humans' informations to remember, to save in the model parameters. Okay, and then foundation model reproduce something, text, image, audio, video, according to user prompt. So that is all. So any generative model, any generative foundation model, that doesn't do anything new. Okay, it is just, I think it's much more better and much more scale than previous model to help people remember, write, draw, compose music, produce videos better. This is all. Yeah, it actually relieve humans' labors in these works. So this is good. I think this is good side. It is a positive impact on humans. This is the creative power. But we have a lot of negative impact on humans or on society. In my experience, I just seen much more fake information, fake digital content over the internet. Say, and I think it's so seldom the website or some company do some fake content discovery and the fake content detection. Yeah, and the second negative point is I think human. I think the human feel at some kind of this model because foundation model companies are doing something. I think something bad. They collecting, analyze, and use user prompt data to train their own models. So their model is get better and better, and the user data is, I think, is discussed or is misused. So I think users' privacy and security are not good and somehow violated. So this is what kind of sort of. But I think we have some. There are some organizations doing some new regulation to control the development of generative AI, control the misuse of generative AI. Yeah.
Well, okay, thank you. So we have several minutes left. So I'm going to open the floor to the audience. So is there any question? Anyone want to ask any of our panelists? Anyone? Oh, go ahead. So can we deliver him a microphone? Yeah, please introduce yourself, who you are, and then ask who you want to ask and what is your question.
May I ask anyone of you? I'm
any of them, or who is the one you want to ask? Well, let us listen to your question first.
Maybe I want to ask Professor Xin-Teng Yao. So all of you have made such a great progress in your each area. So I want to ask how to be creativity and how to keep this creativity. Thanks.
Well, it's also for our today's topic. Okay, how to be creative? How can be someone like you? Maybe this question are the best is Professor Yao. His question is quite creative.
Well, not crazy, but human beings learn to be creative based on many factors. And an important thing is that human beings learn creativity by making mistakes. It's something that machine did not know how to do yet. We make maybe 100 mistakes before we make one more step up. And this happens all the time. I think every mathematician knows you want to prove a deep freedom, you probably make at least 10 mistakes, mostly 100 mistakes before you move up. And you learn how to understand the structure of the film or, deep structure by making mistakes. You do not do it purposely, but you automatically will make mistakes. And then you may not know the mistakes for a long time, and then you keep on digging up the structure behind it. You learn by association, by going to different subjects, go to physics, go to, you learn geometry, you may go to differential equations, you may go to many different subjects. And these are the way that we learn to be creative. And of course, you need to know your own subject very well. So it's a very complex creature to be creative. But I tell you what my way of thinking is, but there are other people who think quite differently. But on the other hand, I do not believe there is such a thing called 天才 or such a thing doesn't exist.
Well, can we human beings invent something we never see?
Well, what do we never see? Of course, we observe things. In the big machine, the big collider, we will somehow find something we never see.
If we never see it, we never know. We don't know it.
That's why we need to do experiment.
For example, if we do not know people can move, a human being can move, then we cannot invent the train, the car, right?
No. We invent a telescope and you observe, you found, many things. You invent a microscope, you see many things. The basic thing is that nature is far, far bigger than what we know. And nature is almost infinite. And if you accept the fact nature is basically infinite, then you never conquer nature, but except learning from it.
Well, yes. Nature has a lot of things, but we practice in the nature, and if we see something in the nature, then we invent something corresponding to the nature things, right?
I think it's the arrogancy of the computer scientists to think that you can beat nature, and I don't believe that.
Thank you. What do you think?
Well, I don't think computer scientists are trying to beat nature, but as far as thinking up new things, I think obviously we have to explore very broadly, and most of the time we make mistakes. But also, I think new ideas come in extremely small steps. So individuals make an extremely small step, and then maybe someone else makes another extremely small step. But if the small step is in a new direction, then people recognize this is something really new. So I think creativity isn't well. Okay, so also for human creativity, I think you also need to have the right environment. You have to allow people to be creative, to give them latitude to explore broadly, and don't examine every second how well they're doing. But broadly speaking, I don't think we can rule out. Okay. So I think one difficulty of discussing AI is because, unfortunately, say up to a few years ago, AI meant some general ambition people had to make machines more capable. But in the last few years, AI has seemed to mean exactly what's achieved now by existing systems. So I think when people talk about AI now, they have restricted their view on what machines are doing currently. I think we should go back and have broader ambitions. And if we do, I don't think there's anything which we can define as human capability, which one can rule out machines also being able to do.
Is generative AI creative or not?
Well, I don't think this question makes sense. Sorry.
I'm kidding.
No, generally not. No, generally not. It can be if it's lucky, but in general, not.
Go ahead, Moti, go ahead.
I think a lot of the attributes that we put on AI or on technology in general is very, it's good for journalists. It's not good for scientists, whether it's creative, whether it is conscious, whether it's this, whether it's that. These are not really something that essential to the issue itself. And also, computing and AI are creatures that were derived from mathematics. And if AI finds a mathematical theorem or helps in doing mathematical theorems, is using mathematics to create a tool that helps us with mathematics. It's all in the system. It's like if I write it, if I think about something and I'm using some mathematical knowledge, then it helps me to get mathematical result. And AI is a way to organize the knowledge and apply it and process with it in a certain way. And one word on creativity, you know, there is perspiration and inspiration. There's a lot of perspiration and very little inspiration. You have to play and play and play, and you have to love what you do, and then exactly you will find the right thing. Otherwise, you're going to give up, and you're not going to have any creativity. It's hard work.
I have one more. Go ahead. Yeah. Well, just based on logic and a machine, you can create infinite number of films. Most of them are junk, as we know. There's a creativity, including a question how to judge whether the film they prove are interesting or not. That is a judgment beyond mathematics or beyond just logic. And it has a great deal to do with nature. That's why I said nature is infinite. Based on what we understand nature, it will bring in the depth of the film that we can prove, and these are part of creativity. Because machines can create infinite number of films, but that's based on logic, A implies B, B implies C. You can keep on generating infinite number of statements, but most of them are nonsense, no interest. They are true facts, but they are useless. So at the end, we have to judge according to beauty as we see it from our inspiration from nature, because anything that are close to nature are good for us. That's our experience. Okay, it's nothing to do with creation. It's just the fact that we see it, and also we live in this. Well, the nature we see would be more adaptive to the film that I prove. That's basically what it is.
Thank you. Anyone want to say something? Okay, go ahead.
Let me provide two very quick perspectives to this. Maybe a student, how to be more creative, maybe in your daily research or daily work. I just want to say two things. One thing is being open-minded, being willing to learn, and embracing inclusion and diversity will help you be more creative. Because you learn new things, learn other disciplines, especially you know those cross-disciplinary things. You will eventually understand the world is so different. People's perspectives are so different. Then you will also be willing to provide different solutions to a problem. And second thing is just remember that you need to aim really high. If your aim is very high, then you will not be satisfied by some incremental solutions, and you will not be satisfied by what you already know, already other people have already invented. You will try your best to do something very unique, because what you have today cannot match what you want to do in the future. So that's big gap will motivate you to be more creative. So this is these two perspectives are really something I practice from day to day. When we do AI for science, when we really do all the research in Microsoft Research, these two things, learning, being open-minded, have a growth mindset, and talk to people with different backgrounds, and also trying to do some mission-driven thing, moonshot level, big project will really give people strong motivation to create something different.
Thank you, Jie. Okay, I think we have a lot of things to discuss, but it's really close to the time limit. So, very quick one? Okay, well, very quick one.
Okay, I just we seem to have a competition between machines and humans about who's more creative. I have a question for the computer scientists. Can AI generate trust? Like scientists, mathematicians prove theorems. Scientists make new results, and those are things that we trust as a civilization, and that's maybe why scientists have gained their status. And I'm very interested in what is the progress on creating trust and generative trust. Like, can AI generate trust? Anyone, please.
Well, I think trust has to be earned. So, so some computer systems are trusted and calculators are trusted, and some systems are not trusted because their behavior isn't because they're not trustworthy. So, I think computer scientists have to make sure that whatever they do earns is worthy of trust. It's not automatic.
Okay, just go ahead.
And yes, sometimes people trust something because of this is the common belief. This is what they learn from their professors. This is what they think it is. But it's not always correct. You sometimes have to unlearn, revise, and then that's a good way to get inspiration sometimes. So I'm not sure that you can mechanize all notions of trust because I don't know we don't know what they are. Trust is
we have to define
in many ways.
Okay, I believe we have a lot of things to discuss, but indeed the chair tells me that yeah, we are very quick. Okay, give to him 2 minutes. 1 minute ask, 1 minute answer.
I'd like to ask distinguished Professor Valiant and Professor Yang, would you please give us the top 5 questions, your personal concern on AI? The top 5 questions. Okay.
Too many.
Just keywords is okay. Just keywords.
Top 5, too many.
Top 3. Top 3.
Top 3 questions in AI. Leslie and Professor Yao. Quickly.
You said concerns.
Concerns or questions?
Your concern. Yeah.
Concerns.
Well, I don't want to trivialize your question, but I think whatever the top 3 concerns of humanity are probably also the same concerns for AI, because everything we do, AI will get involved in.
I've said whatever I said. I don't want to answer.
Okay, so indeed, we have no time. I was invited by Professor Hu Shimin to this event. Thank you so much for the invitation. You have something to say? Well, okay, come up. Yeah, say something, yeah. Okay, well, and also thank you for your kind organization, the invitation, and also the presentation today. So, Ace, thank you so much. Let's thank all the panelists. Thank you so much. I'm going to deliver this one back to Song Hai. Yeah, thank you so much.
Thank you, Professor Liu. And to all our distinguished panelists for truly enlightening and engaging discussion. So your insights have provided us a deeper understanding and exciting future of computer science. As we continued, we now move to the next demo show session. Here, we will witness the latest innovation and advancements in computer science, showcasing the cutting-edge projects that push boundary what is possible. The first presenter is Professor Ravi Ramamurthy from University California, San Diego. Please.
right. So I'm going to talk about our work on local light field fusion. We want to be able to produce immersive visualizations of scenes like this from a few images, but it's typically been very hard. You could take a bunch of pictures in an irregular fashion, and you could try to reconstruct some notion of the object geometry, in this case a mesh, but typically that's very error prone and you get errors. On the other hand, you can actually exhaustively sample the scene based on Nyquist sampling theory, which effectively means the disparity or motion of the closest point is less than 1 pixel between images. And this enables you to do very small baseline immersive views like this, but it's not useful in general. So in practice, you've got to break the Nyquist limit and have a sparser sampling. And you can try to do that with various light field rendering and optical flow techniques, but often you get artifacts and there's no clear understanding of how many images is actually enough. So what we introduce in this work is a method to use an irregular grid-based sampling, where you actually have formal limits based on sampling theory of what the sampling rates should be. Now, you have a simple app to capture this. It can just be done on a mobile device, and you will have guaranteed of where you need to sample. We actually show that you can reduce the sampling rate by a factor of 64 in both dimensions, so by about 4,000. From the image, you actually recover what is known as a multiplane image. If you use a single multiplane image, it's just a bunch of planes, you can get some artifacts when you extrapolate beyond that. So what you do is you promote each individual image into its own light field based on this multiplane image, and then you blend the light fields of all the individual images together. Now you can see that you get the nice reflections on the puddle, the nice highlights from the bike, and you can even do this on a mobile device. It allows you to take your 2D images and now view them in 3D. To show the robustness of the technique, these are demonstrations in about 60 scenes, and you can see that they are fairly complicated scenes, each case just 20 to 50 original input images. It includes flowers, it includes foliage, it includes people, and all of these are captured by taking a few images, and then you can view them immersively. If you want to know more, including newest developments, come to my talk at 1:30 p.m. tomorrow.
Thank you. The second presenter is Dr. Ji Jiezhongqiu from Zhejiang University, Zhejiang Lab, please.
Good evening. It's my honor to introduce our research in graph neural network retraining on behalf of myself and my PhD advisor, Professor Jie Tang from Tsinghua University. My talk will share insights from our paper, Graph Contrastive Coding for Graph Neural Network Training, one of the most cited papers at KDD 2020. In the era of big data, we are surrounded by large-scale complex networks, social, commercial, and information. Our mission is to harness these networks' power through graph neural networks, translating their structure to vector space. This transformation enables deep learning models to discover valuable patterns, offering insights into the underlying mechanism and dynamics of these networks. Our innovative approach, graph contrastive coding, aims to pre-train GNNs on diverse social and information networks like Facebook, IMDb, and DBLP. The pre-trained models are then fine-tuned for various tasks and datasets. Our vision is to capture and transfer the universal graph structure patterns across networks. GCC is inspired by contrastive learning, a very popular pre-training technique in computer vision, which aims to differentiate between similar and dissimilar pairs of images. We apply this technique to graphs by sampling subgraphs through random walks, ensuring that graph GNNs learns to distinguish similar and dissimilar pairs of sampled subgraphs. Graph contrastive coding offers two fine-tuning strategies. For fine-tuning, where both the GNNs and the classifier can be tuned on downstream tasks, and freezing fine-tuning, where the GNNs act as a static feature extractor and the classifier learns. Our experiments reveals that freezing fine-tuning holds its own against supervised models trained from scratch, while for fine-tuning pushes performance even further. This demonstrates the remarkable potential of pre-trained graph neural networks in a variety of graph learning tasks. In today's talk, we've traversed the landscape of graph neural network pre-training. Thank you for joining me on this journey through the event of computer science. Thank you.
Thank you. And the other two presenters are not here today, so please enjoy these two demo videos.
We need more data. Modern AI platforms are capable of making sense of many things, but they need real-world data to build models. Conventional cameras are on the human scale. They capture images on a scale that humans can see and interpret. Machines need data on a larger scale. For this purpose, we have constructed parallel super cameras. Here we see the assembly of the world's first gigapixel camera, the Aware 2. People are busy here putting microcameras into a dome that looks through a spherical lens that captures the field. Here on the front of the camera is the spherical lens, and here at the back we see all of these strands correspond to 14 megapixel microcameras. Up to 200 microcameras are put in the dome to capture gigapixel video. Using the cameras, one can capture events in detail. Here's data from an Aware 2 at an American football game. All of the zoom is digital. You may be used to pan, tilt, zoom in a camera, but you are not used to cameras that can freeze time and then pan, tilt, and zoom. So here, as we zoom in, we've frozen time and can look anywhere on the field to see what's happening at that instant. We can go back in time and forward in time and zoom around and look anywhere we like. So here we're watching the player run around the end and score a touchdown. And then we can zoom out and see how everyone on the field reacts to the touchdown. Here's the next generation of this technology built by the spin-off company Acuity at a Chinese football game. Again, all of the zoom is digital. Note that as we switch data streams, as we zoom in and out, you'll see some low resolution video as we're processing the codec. Basically, the camera, in this case, is a parallel supercomputer that happens to have sensor nodes in addition to processing nodes and memory nodes at each node in the architecture. So basically, the modern camera is software-defined, a parallel supercomputer with embedded processing. Here we see the camera again here in Beijing. Now, if you look at this scene, you see a scene with blue sky, but a camera with this kind of resolution can zoom in and find things in the sky that could never be found even by a pan-tilt zoom camera, because how would you know where to look? But a super camera captures the entire sky. You see two planes that were not visible, and then as you pan and zoom and zoom and zoom, you see something in the sky that never would have been found, except for the fact that the camera is able to see this plane far off in the distance. And then we can zoom back out and see the scene once again on the human scale.
Hello, I'm Xiaolei from Graphics and Geometric Computing Group at Tsinghua University, advised by Xinmin Hu. It's my great honor to introduce our recent work here, DScene, Object Decoupling and Interaction Modeling for Complex Scene Generation. DScene takes a complex long scene description with multi-objects and their relations and generate 3D assets with decoupled objects and modeled interactions, which is challenging in industrial 3D content creation. We introduce a clear definition on how complex 3D scene generation with distilling knowledge from 2D diffusion models should function in real-world applications. Besides, we propose a novel method, desync, utilizing a learnable structure scene graph as compositional representation for complex scenes. Another key contribution lies in that we propose a novel object-aware rendering for optimization, achieving clear and sharp boundaries between contacting objects. There are some visualization results with full generated scene and decoupled objects. Another application of desync lies in controllable scene editing, which benefits from the complete decoupling of objects. Additionally, we demonstrated the potential to directly integrate desync generation results into industrial 3D production pipelines, which can avoid overly burdensome workflow stages, such as pre-visualization. We'll release all codes soon, and feel free to email me if you have any questions or thoughts. Thank you for your attention and support.
Okay. So thank you. Thanks to all presenters. Here we'll particularly thank Tencent. Next page. Next page. Please. Okay. So we particularly thank Tencent for providing sponsorship to this event. Now it's time to relax and enjoy dinner. It's a wonderful opportunity to network, share ideas, and continue our discussions in the more informal setting. So dinner will be served in main hall. Please follow the volunteers and enjoy the rest of the evening. Thank you.